In the previous videos, we talked a lot about how the natural sciences had more success at making accurate and reliable predictions than the social sciences. This is of course not the fault of social scientists, but stems primarily from the fact that the social sciences deal with irreducibly complex systems. Or, said in different words, that there are always multiple effects going on at the same time from which it is impossible to isolate an individual effect. This is as opposed to the natural sciences, where it is possible to isolate the elementary effects. So, if we wanted to, say, determine the effect that an electric field has on the motion of electrons, we could set up an experiment where we compare the motion of electrons without an electric field and with an electric field, allowing us to exactly determine the effect of the electric field on the electron motion. Now, as we are dealing with the real world, there are various outside influences that will mess up this experiment, such as the Earth's magnetic field and radio waves. On the causal graph below, we draw arrows to show that the Earth's magnetic field and the radio waves also influence the motion of the electron. Fortunately, we are able to shield the experiment from all the interfering effects. By removing the interfering effects, we can isolate the effect of the electric field on the electron's motion and get a complete and accurate understanding of it. Unfortunately, isolating an individual effect in such a way is not possible in the social sciences. If we wanted to, for example, determine the effect of eating ice cream on someone's happiness, then we could perform a study where we look at people's happiness without ice cream and with ice cream. Here also, there are interfering effects. For example, the participants' happiness will be influenced by knowing that they are part of a study and being observed. Their happiness will also be influenced, for example, by their environment, the time of day, the weather, and the mood of the researcher that they are interacting with. We can draw these influences on the causal graph, like this, not to mention all the other effects that are going on, such as the researcher's mood being influenced by the time of day, the weather, and the participants' happiness. And of course, the unfortunate fact that we cannot observe happiness directly, but only indirectly via a questionnaire, which in turn also influences the participants' happiness. Now, typically, we will try to design our experiment so as to avoid as many of these influences as possible. For example, we can perform our study at different times of day to eliminate the time's influence, and we can make a double-blind study to remove the researcher's influence. But whatever we do, we will always be left with many corrupting effects. What does that mean for our data? Well, even if the effect we are studying is strong, the other effects also influence the observed happiness and corrupt our data. The other effects add so-called noise to our data set. This noise is a massive problem for social science researchers. It affects practically every data set, making it impossible to accurately measure anything. Not only does it make the exact study of effects impossible, it often corrupts the data to such a degree that we aren't even sure if the effect exists at all. Or, in other words, due to the noise, it is often hard to find statistically significant evidence for the mere existence of an effect, not to mention its exact shape. There currently is no solution to this problem. Due to the noise, many things simply cannot be studied, and most of the other findings are made somewhat unsure by it. As you may imagine, this is a massive obstacle standing in the way of all quantitative research. Tree of Knowledge offers a partial solution to this noise problem. The solution comes from realizing that noisy data like this is not the observation of a single effect with some random error, as statistics may have you believe, but that we live in a deterministic world where there is no true randomness, and that all seemingly random spread comes from interfering effects. Now, at the core of the online platform Tree of Knowledge is a human agent which has been built up and extended by the work of many different researchers. These researchers added new behaviour rules to this shared agent in pursuit of their personal research questions. For example, There might well have been some researchers studying influences on a person's happiness. As part of their investigations, they will have created new rules about these effects, such as how weather affects someone's happiness, how the environment affects happiness, or how being surveilled affects happiness. And as part of their investigation, they will also have fitted, evaluated, and optimized these rules on the dozens of relevant datasets in Tree of Knowledge. Now, there is an immense value in having this shared agent with pre-trained rules of so many different effects, as the shared agent will contain accurate rules for at least some of the interfering effects that exist in our dataset, such as the weather's effect on someone's happiness, the environment's effect, and the effect of being surveilled. Knowing these rules allows the software to automatically calculate out these effects from the data, and thereby remove much of the interfering noise. By calculating out the interfering effects like this, we won't be able to completely remove all noise and completely purify the ice cream's influence on happiness. This is due to faint vestiges from inaccuracies in the removed effects, and because there might be effects for which we don't yet have a trained rule. However, even by removing just some of the interfering effects, we already get data that is significantly more informative and useful than what we had before. Improving the data quality in such a way opens up many areas of social science research that previously had been too noisy for any serious investigation. And it can significantly increase the accuracy in the existing areas. This effect will only increase with Tree of Knowledge's growth, as over time more and more of the interfering effects will have been modelled with an increasing accuracy, allowing us to completely blow away the fog of noise.